Okay, now if I can keep this straight, we'll be doing okay. But I've got like a million papers in here. I'm afraid I'm going to get messed up. Now, let's see. Okay. Let's see. Okay, this is kind of hard to see from here, but okay, we had a test, and then today we're going to finish chapter 9, which you can't see that from here. Okay, let me see. Okay. Anyway, and then we're gonna be out like the next 3 times, okay? But I'm gonna do a video of the next chapter, and I'll send you a note, you know, on Populi on what to do, or Tegrity, or what. I never know which one's which, but anyway, and so we'll do like chapter 11 and 12 on that, and then we'll come back on December the 5th and do chapter 13 and review. Now on the day that we have the forum, which is the 28th, I will be here, and if you are at the forum anytime and you have a question, I can leave there and come help you with whatever it is, okay? Because this next part that we're going to go over is going to get, you know, yeah, pretty bad. So anyway, I mean, it may be bad, it may not be bad for you, but it could possibly be bad. Okay, let's check first 9-1. I think that was 45 through 69 odds and 75 through 85 odds. Is that right? Yeah. Okay, 9-1. Okay.
Can we go over the 75 through 85?
Yeah, we'll go over any of them that you need to see. Can do is try, you know. And what's bad about this is a lot of this is supposed to be, oh, that's not working. Oh well. A lot of this is supposed to be a review, but to some of you it may be the first time you've seen it, or you just may not remember any of it. And so that makes it, you know, real hard to get all this at one time. Okay, but what we did, we talked about points, lines, and planes, and rays, and angles, and intersecting lines and planes, and all sorts of things in there. And then we talked about like corresponding, alternate interior, vertical. So you had a lot of terms. And with geometry, it's different from algebra in that when you're studying it, you pretty much have to memorize all the terms and everything. Most math things you don't have to. You just, you know, you either know it or you don't know how to do it. But with geometry, you usually have to memorize. Okay, now, so the ones that we were doing was like, let's see, 45 through 69. Okay. All right, so 45 through 62, classify that as acute, right, straight, obtuse, or none of these. So on 45, let's look at that in the book, and we'll go over it a little bit to refresh our memory. And I can't get this any bigger for some reason. It's not doing what it's supposed to do, and I don't know why. But
you try Control Plus?
Anyway, well, it's this thing that's supposed to do it. It's supposed to, you know, make it, and it's just not working for some reason. Okay. But anyway, this one is an obtuse angle. It's more than 90. 47 is a straight angle. 49 is a right angle because it has that little box in it. Okay. 51, now notice on 51, that the angle symbol goes around this way. So that's why it was none of these. It doesn't, if it had been in here, it would have been acute. But because it went around there, it was none of them. Okay, then find the complementary angle of the given angle. Okay, complementary angles are two angles that add up to 90 degrees. Okay, so on 53, you say 90 minus 19. 55, you say 90 minus 32 and 3/4. 57, 90 minus 64.7. These supplementary are two angles that add up to 180. So on 59, it's 180 minus 91. 61 is 180 minus 20.5. 63 is 180 minus 43 and 5/7. Okay, then when you get up here, match the names of the angle with the corresponding figures. Okay, now, let's see. All right, on 65, okay, you had this, and you had this angle right here, and this one right here. Okay, we did not talk about that. Okay, we talked about this one and this one would be like vertical angles, and this one would be corresponding. But the two that we're talking about here are like alternate exterior. They're on the exterior of the two parallel lines, so alternate exterior. But I don't even think that was one that we mentioned. Okay, 67. Okay. Okay, let's see. 67 supplementary angles. Okay, the ones that are supplementary would be C, right? Angle 1 and angle 2. Okay. Alright, 69. The ones that show alternate interior angles are E. Okay, alternate interior would be this one and this one. They're on the interior of the parallel lines, and they alternate. One's on one side of the transversal, one's on the other. Like that. Okay. On 75, determine the measures of 1 through 7. Okay, always when you have these types of problems, draw your own picture, okay, and draw your parallel lines, and draw your transversal, okay. Now what I do, I don't put any angle numbers in there, because sometimes the angle numbers get you mixed up with the actual measure of the angle. So I'll say this is 125, so that's 125, because vertical angles are equal. And then if this one is 125, then this one is 125, because they're corresponding or alternate interior are the same. And then that one is 125. Okay, so all those are equal. All the rest of them are equal to 180 minus 125. Okay? Is that right? Okay, so all the rest of them are 55. But always draw your own picture, because if you don't, you won't be able to see it. Okay. Now 77, especially if you didn't draw it, it would drive you crazy trying to figure that out. Okay, now these two angles are parallel. This is the transversal, and they give you one angle, which is right in there, of 25 degrees, and you have to find the rest of them. Hey, so you made it, huh? Bad day to have car trouble in the rain. So that's 25, that's 25. Then this is 25, this is 25. Okay. Okay. Because this one was 25, this is a corresponding angle, so it's also 25. These are vertical, so they're going to be equal. Then the rest of them, see, that's a straight line. You always find your straight lines. And so 180 minus 25, is that right? Okay, so that would be 155 for the rest of them. Okay. All right, now, do number 78, just somewhere on your paper. Work that one. And that's 120 in there. But notice how I don't put the numbers of the angles in there because that gets it confused. Yeah, I mean, you know. But if that's 120, this one is 120, right? Because what type of angles are those?
Jeez.
Vertical.
Oh, yeah.
Or vertical. Okay. If this one is 120, this one is 120 because those are corresponding. I can also know that they're the same because those are alternate interior. And if this one's 120, then that one's going to be 120 because vertical angles are equal. Now, you find a straight line, which is equal to 180. So if this one is 120, how much is this one? 60. Okay. And then all the rest of them will be 60. So all you got to do is put 60 in for the rest. Okay, got that figured out now. Okay. Now on 79, same thing. They put too much information on there and it makes it hard to do. Okay, this one is x. This one is 3x plus 10. See how much easier that is to see than the way they have it on there? They got the 1 and the 2 in there, you know. Okay, so these two, it says the angles are complementary. So what does that mean? Equals 90. Complementary is 90. Supplementary is 180. So that means this plus this equals 90. So all you have to do is write it down in equation form and then solve it. This is why before you take geometry, you have to know algebra. So combine your like terms. That's 4x plus 10 equals 90. Subtract 10. 4x equals 80. And so is that 20? Did I do that right? Okay, so this one is 20 degrees. This one will be 3 times 20 plus 10, or 60 plus 10, or 70. You can also just say, if those are 90 degrees, 90 minus 20 is 70. You know, you didn't even have to go through that right there. But that's kind of a check on it. Okay, does that make sense?
Did you write x plus 2x or 3x plus 3x?
X plus 3x plus 10 equals 90 because this angle plus this angle equals 90.
So that 2 in the first part of the angle, that's just irrelevant.
That's just calling that angle 2 and calling this one angle 1. Because when you get through, they want to know what angle 1 and angle 2 are equal to. But if you draw a picture, you've got it, you know. Okay, let's look at another one. All right, let's say 81. All right, you've got this. And the 1 and the 2 are just talking about the angles. This one is x. This one is 2x minus 9. Right? Okay, so it's easy if you don't have the 1 and the 2 in there till you get through. Now, it says all of these are complementary, so they're going to be equal to 90. And you just add that together. Okay? So that's a 3x minus 9 equals 90 and work it out. Okay, what was x equal to on that one?
90? No.
Is it 33? 33. And then 90 minus 33. Is that 57? For that one. And then check it to see if these two do add up to 90. Okay. All right, so that's the way you do these problems. Now, you work number 82 somewhere on your paper.
That's from last week, and then, some notes from last week. This, see that, this is 6.1 through 6.6, and then 6.7.
Okay.
And I took notes on the video, so do you need to see the notes, or is that?
It's fine.
How come with 81 we right?
So you'll come down these two.
Did we do that with 79? That X on the 3X? So that would have made it 4X? Okay. Okay. So that would bring it to 0, right? 8X.
Oh,
8X.
I think so. Okay, so all of these are complementary, so they all equal 90 degrees. We write x plus 8x minus 9 equals 9. You'll make an equation on each one of these. Combine like terms, so that's 9x minus 9 equals 90. Remember, these are alike. These are like terms. Okay, so 9x minus 9 equals 90. Then we add 9 to both sides, so 9x equals 99. So x is 11. Good. Okay. Now, if you have a little trouble with your algebra, you're going to miss your geometry problem. Okay. All right, but if x is 11, so this one is 11. So 90 minus 11 will give you the measure of that one. Is that 79? Okay. So 79 and 11 do add up to 90. Sometimes they will just draw the picture like this, and then you will know that they equal 90. On this particular one, they said they're all complementary. So they're wanting to make sure you understand what complementary means. It's two angles whose measures equal 90 degrees. Okay, so that's the way that one is. Anytime if I go too fast on the notes, just let me know and we'll do it. Okay, the next ones it says they're supplementary. So there's 83. So we've got this, and we have this. And the 1 and the 2 are just showing you which one is angle 1 and which one is angle 2. Angle 2 is x, and this one is 2x minus 15. Okay, write down the equation. And of course, most of you have already done it. But on these, you put them equal to 180 because it's supplementary. So it looks like that. This one plus this one equals 180. Then you combine like terms. Then you add the 15 to both sides. Then you divide by 3. Is that 65? Okay. So x is 65, which is the same thing as angle 2. Okay. All right. So this one's 65. To get the other one, you say 180 minus 65. You can also say 2 times 65 minus 15. Okay. So what'd you get over here for this one?
115.
115? Okay. I'll take your word for it. Okay, now, sometimes they will have the picture drawn the wrong way. And they might have, you know, that x is 65, but they might have it over here you know, and it's really supposed to be an acute angle, and they have it drawn as obtuse. They're just wanting to see if you know what you're doing. Okay.
So,
Right.
whenever we're trying to find answers
Mm-hmm.
for this, are we primarily trying to find? Okay, I see what it says. Okay, so we're finding x, but
Uh-huh.
we also want to make sure we write down
What angle is
each
what?
angle is.
Yeah, because on 83, this is angle 2. So the measure of angle 2 is 65. The measure of angle 1 is, what did we say it was? 115. Okay. That's the final answer that they're going to ask you for. Okay. But a lot of times, if you have this drawn, you know, I can figure out what you've got. Okay. All right. Now, 85 is the last one. Some of you have it done, some don't. Okay. So let's look at it. This one is x, and this is 5x plus 6. So what you're doing really is just practicing working your equations. Wait a minute. Whoops. 12 on that. Right, is that right? So x is 29, and then 180 minus 29 gives you this one, and how much was it? One what? 151. Okay. So there's your two answers. Alright. So angle 1 was 29 and angle 2 was 151. Okay. Alright, you do number 86. Just do it somewhere on your paper. Did you get 25 for x? Okay, good. Alright.
I
Mm-hmm.
just found out an easier way for me to do this is literally do it backwards. Like take the 180 minus or plus the 5 and then divide it or multiply. And I don't know why that works. It does though.
Okay, whatever. Okay. Alright, now, so we had plane. What are the three undefined terms of geometry?
Points, plane, and
Line.
Yeah.
Point, line, and plane. Point, line, and plane. Okay, they were so simple that Euclid didn't even come up with a definition for that. What was the name of his book?
oh, I've written it down.
Enjoyed that question too much.
The elements?
Yes, the elements. Okay. All right. If I had, what is this called?
Those 2
A
points,
segment.
line segments.
Segment. What is this?
Array.
Array. What is the, where does this ray originate? At A or at B?
A.
A. If I want to write ray AB,
Mhm.
see, it originates at A and goes through B. Okay. This could be a line. If I wanted to talk about that line, it would be line CD. I can also put like a L there and call it line L, whatever. If I have this, okay. Which one is the vertex?
B.
B is the vertex. Okay. All right. How many different ways can I name this angle?
Angle BC, or BAC, angle ABC.
Angle ABC is one.
CBA.
CBA.
So never start from the
B.
vertex?
Mm-mm.
Okay.
Angle B.
Angle B.
Angle 2.
Angle 2. Good. Okay. So you can go this way, that way. You can call it by the little angle symbol in here, or you can call it by the vertex. But when it's 3, the one in the middle is the vertex. Okay. All right. If you want to talk about a plane, you just draw a shape like that, and we can call this plane M. It's a capital, cursive, letter, whatever. If you want to draw parallel planes, you can do them one on top of the other like that. Sometimes they will have a line like this going down through there, showing that, kind of like that there. Right. So, and it's kind of hard sometimes to draw these things on here. Okay, now, the next thing that we're doing is we're talking about polygons. Okay, look on page 485. Okay, this is 9.2. Okay, a polygon is a many-sided figure. That's good definition. Many-sided figure. Okay, if it is a regular polygon, it has equal sides and equal angles. Okay, I'll show you what I mean by that. This is a triangle. It is considered a polygon. It is a many-sided figure. Okay. If I draw it like this and put those lines right there, that means that the angles are all equal and the sides are all equal. Okay. But this is a polygon. You don't have to put this on there if you don't want to. And this is a regular polygon. Okay, so this one is regular. Equal sides, equal angles. Okay, but it's still a polygon. Now, look on page 485. Triangle, 3 sides. Quadrilateral, 4. Quad means 4. Penta, 5. Pentagon. Hexagon, 6. Heptagon. A heptagon might be one that you're not as familiar with, but it's a 7-sided figure. Octagon, 8. Okay, think of an octopus. Okay, nonagon is 9. That's one you're probably not familiar with. Decagon, a decade is 10. Okay, dodecagon. Okay, so 12. And a cosagon. Okay, so some of those you're familiar with and some not. But just make sure you know those. Okay. Now, the next part that they're trying to explain to you, I may or may not be able to explain it, but I'll try to. You do not have to to draw this picture or write anything right now. Okay, we've got parallel lines right here. Okay, and it says that, like, alright, this is like A, B, and C. That's A prime, B prime, C prime. Okay, C prime there. And then, okay, they're saying that you can see that this angle and this angle would be the same because they're what kind of angles?
Vertical.
Vertical. Okay. Now, if I took this one, you see how it would be equal to this one over here? Okay. All right. Then, if I don't look at anything else, and these are parallel lines, can you see that that one and that one would be equal to each other?
Which ones?
Alternate interior angles. Okay. And then, if we have, let's see, this one and this one are the same. A prime and that one right there are the same. And this one would be the same. Okay. Now, they're saying that this is a straight line and all of these add up to 180. Right? Okay. Then they're saying if you take, see this was 1, 2, and this one had 3 on it. So 1, 2, and 3. All of those added together would equal 180. They're proving to you. And when you're in, regular geometry in high school, you had to actually write that in the form of a proof. But I showed you that they were vertical, these were alternate interior. So that one is equal to that one. Okay, and then this one is equal to this one, and then this one's equal to this, and this is equal to this. Okay, so if those 3 add up to 180, then these 3 have to add up to 180. So the measures of the interior angles of any triangle are equal to 180. Okay, now, alright, so write that down somewhere. The measure of the interior angles of a triangle are equal to 180. Okay. And interior means inside. The measures of the interior angles of any triangle. It doesn't matter the shape of it. They're going to equal 180. If you have a triangle shaped like this, it's still going to equal 180. If you have one like this, it's going to equal 180. So forth, so on. Any triangle, the measures of the interior angles are equal to 180. Okay, now, if you take another figure, let's say one with 4 sides. What's a 4-sided figure called? Quadrilateral. Good, quadrilateral. Okay, if I divided it up into 2 triangles, say I just drew one diagonal line across it. It's 2 triangles. So, if I had this shape before I divided it up and I added this, plus this one, plus this one, plus this one, it would equal 180 and 180, or 360. You don't have to draw any of this either. Alright, if I took this shape, what is it? Pentagon. Alright, let's just take a vertex over here and draw lines. How many triangles do I have? 3 triangles. So 3 times 180 will give you 540 degrees. So if I added up the interior angles, this one plus this one plus this one plus this one plus this one, it's going to add up to 540 degrees. You can take any shape and divide it up into triangles and figure out what the measure of all those angles. Why anybody wants to know that? I have no clue. But anyway, we might need that someday. Now, there is a formula that you can use to represent this, and that is n minus 2 times 180 gives you the measures of the interior angles of any polygon.
So in theory, every time you add a line, because a line is 180, you're basically adding 180.
Uh-huh.
Is that correct?
Mm-hmm. Okay, now, you can take your shape. I wish I could make it bigger, it just won't go there
It's
today.
just, I had eye surgery a couple weeks ago. so it's
I
cool.
know. But see, before you got here, I was trying to get it to, get bigger, and it won't do
Out of
it.
focus, yeah.
And it just won't get bigger. Usually you just mash it, and it gets bigger and bigger and bigger. But it won't do that today. Okay, now, so we took a quadrilateral, and we divided it into two triangles, so that's 2 times 180, or 360. Now, I can also use this formula. How many sides does it have? 4 minus 2 times 180. So that's 2 times 180, or 360. So I can physically figure it out, or I can use this formula. The number of sides minus 2 times 180 will give you the measures of the interior angles of any polygon. Okay, so you can try that. Let's say it was a 12-sided figure. What's the name of that? Dodecagon, right. Okay, now I don't want to draw a 12-sided figure and draw all that kind of stuff, so I can just do 12 minus 2 times 180,
So
or 10.
1,800.
Uh-huh.
That's a lot of
Oops.
that's a lot of degrees there.
Right. Right. Anyway, whatever. Okay. All right. Now, let's see. Okay, the next thing we have is classifying triangles. And you will need to study this just a little bit, and that's why I'm trying to help you by asking you, different things, to get it in your brain. All right, we can classify triangles by their angles and also by their sides. Okay? If I have a triangle like this, it has 3 acute angles, so it's called an acute triangle. Okay? I can have a triangle like this. It has an obtuse angle, so it's called an obtuse triangle. If I have one like this that has a right angle in it, it is called a right triangle. So I can classify triangles by their angles. Okay? All 3 are acute. It's an acute triangle. One is big, obtuse. One is right. It's a right triangle. Remember, acute, they're real cute. They're little. Okay, and obtuse, big. Okay. All right. Now we can also classify them by their sides. Okay. We can do like this. And when you put the marks on it, that means they're equal to each other. If they have 2 equal sides, it's called isosceles. I hope I spell that right. I'm a terrible speller. Okay, isosceles. If all 3 of them are the same, it is equilateral. Okay, and then if okay, I have something wrong in my notes here. Okay, if none of the sides are the same, it's called scalene. Okay. I've been teaching this for I don't know how many years. I have it. Had something wrong in the notes. Okay, now this is also on the chart on page 487. Okay, so let's look at that a minute. Okay, so you have the triangles according to their angles, acute, obtuse, and right, and according to their sides, isosceles, equilateral, and scalene. Okay. Now, so we'll look at something and you'll have to decide if it's according to its sides, if it's a scalene or if it's isosceles or whatever. You'll have some problems like that. Help get this in your head. Okay, the next thing we have are similar figures. Okay. Similar figures, they basically have the same size and shape, same shape, you know. But they're different sizes. Okay, now, the real definition is that the angles are equal and the sides are in proportion. Sides are equal and the sides are in proportion. Now, example of this, let's say we have a right triangle like this, and then we have a bigger right triangle like this. Okay, so they're the same shape, they're just different sizes. Okay, and if I have this drawn right, this side goes with this one goes with this one, and that one goes with that one, and they're in proportion. Okay, now, let's say we have, and the symbol for similar figures is like this. This little squiggly line like that, like there. Okay, now, I can put, if this is 3, and this is 6, and this is 4, and I want to know this one. Okay, I can set it up in a proportion. Okay, so I can say 4 is to X. You see how that one goes with that one, and this one is to this one. Okay. So I can go this is to this as this is to this. Now when you're working with a proportion, you have to match up the corresponding sides, the ones that go together. I can also say 4 is to 3 as X is to 6. You see how that makes sense? This side to this side as this side to that side. 4 is to 3 as X is to 6. I can say 3 is to 4 as 6 is to X. I can even go this one, X is to 4 as 6 is to 3. What I cannot do is say 4 is to X as 6 is to 3. See, I went from the first one to the second one, and then I did the second one back to the first one, so that didn't work. You got to go first to second, or big to small, big to small. You know, you got to do it the same way. Now, we have it set up in a proportion. Now, when you're working with a proportion, they're really easy to do. You multiply these two together, 4 times 6 is 24, and these two together, 3x, and then solve for x. That's 8, right? Okay. All right, so proportion is real easy to work. Now, what if I put a 5 right here, and I wanted to know y over there? Tell me how I could set this one up. I have to use numbers that I have, like, have sides that both of them have numbers. You see how these two have numbers? I can say 3 is to 6 as, how am I going to find y? What matches up with y?
5.
5. As 5 is to y. So if you're comparing two figures, you find the two sides that both have numbers, then you can do two other sides. Now, they cross multiply, 3y equals 30, so what's y equal to? 10. Okay, so that is similar figures. Now, you can use this to work some different problems. I'll show you just a minute. Like I said, if you need any of these, don't get to look at it long enough, just come get it. Okay, I have this person over here, okay, and I have a tree over here. Okay, now I know that this person is 5 feet tall, short person. Okay, and then he cast a shadow 10 feet long. The tree cast a shadow 40 feet long. Okay, so I can set up triangles, similar triangles, and figure out how tall that tree is. And when I taught middle school, we'd actually go outside and do this, you know, and see the shadow and measure it and all that kind of stuff, you know. Okay, now, these two figures are similar. Now tell me a way that I can set this up. Find the two sides that what?
Go again.
That go together, that both have numbers on them.
5 is to X, what 10 is to
Good.
40.
Good. See, this is what we're trying to find. The height of the tree, 5 is to X, as the shadow is to the shadow. Okay. Multiply. Is that 200? Okay. And then what's X equal to? 10. No,
20.
2.
how much?
20.
10 into 200.
20.
Mm-hmm.
It's going really well
Right.
today. I got the end result, but I do not know the formula. I got the end result.
Okay, so the tree is about 20 feet tall. Okay, now when you get into like algebra 2 and stuff, you do trigonometry, and you can use the angle of this part right here, and you can, don't put that on your paper, but anyway, you can use trigonometry and figure out how tall a tree is and stuff. But anyway, okay, so you're going to use, this is a ratio, and you're setting it up to a proportion. And so this is to this, as this is to this. Now I can also say 40 is to 10 as X is to 5. I can say 5 is to 10 as what?
As X is to 40.
40, good. Okay, what I cannot do is say 5 is to X as 40 is to 10. See, if you do the first one to the second, you got to do the first to the second. If you do
First to first.
first to first, second to second, good, very good. All right, now next we have congruent figures. Okay, if they're congruent, they have equal angles and equal sides. Okay. Let's see. Okay, now if you need more practice on any of this, there are examples on page 488, 489 of a person in a tree and doing the same thing, on that. Congruent figures are down at the bottom of page 489. Okay, now, let's see. Okay, sometimes the congruent figures get a little bit strange. Okay, if you look at your problem down there, I don't have another problem on this. Okay, they have this one as A, B, C, and D, E, F, and this one is 34. This one is 65. This is 12, 11, and X, and this is a 7. Okay. Now it looks awful, doesn't it? Because you got to find the length of these different sides and the measure of these different angles. Now, the key is that A, B, C is congruent to D, E, F. Okay, triangle ABC is congruent to triangle DEF. That tells you how these match up. Okay, now what I always do on these kind, I've got this one. I would take my ABC, and you don't have to write this in your notes because it's on the book, but you really just need to watch and see how to do it. Okay, so ABC goes with DEF. So D would go here, E would go here, and F would go there. Okay, A, B, C, D, E, F. You have to match up the vertices of these. Alright, so this one is 12, this is X, and this is 11. DE is 7. Alright, measure of angle F is 34. The measure of angle A is 65. You see how when you match them up together, and they're supposed to be congruent. I didn't draw it too well, but they're supposed to be exactly The angles are supposed to be the same and the sides are supposed to be the same. So if this is 65, which angle over here is 65?
D.
D. Okay, because it corresponds with it, because that told us that it did. Okay, now, so if this one is 34, then that one's 34. Now all we got to do is figure out that one. Okay, what are the measures of the angles of any triangle equal to? 180. So we add 65 and 34 together. Is that right?
Yes.
Okay, and then say 180 minus 99. Okay, so that one's going to be 81 and that one's going to be 81. So if you know the measures of two angles of a triangle, you just add them together, subtract from 180 and get the other one. Now, if this is 7, it corresponds with that, then x is 7, right? If this is 12, what's this?
12.
12, okay. If this is 11, then this is 11. Okay, now, I could look at that all day like that and it would not make any sense to my brain. But if you match them up, then you can tell exactly what goes with what in order to work the problem. Okay, so you had to find the length of DF, which we did, okay, wherever that is, okay, and the length of AB, which we did, and the measures of all those different angles. Now notice that on C, measure of FDE. That means FDE, that means that one right there. Because when you've got 3 letters, FDE, that's the vertex of the angle, FDE. So they wanted that one. Okay, now then it gives you the answers on the next page. Okay. Now, tell you're going to have quite a lot to think about here, but I think we can do it. Okay, now the next thing we have are special quadrilaterals. What's a quadrilateral? Four-sided figure. Okay. Now, so there's a chart here in the book, and I'm going to give you a chart. Let's see. To help you remember the definitions of these. Now keep in mind we've already been through half of the geometry book, the high school geometry book. So, in a day and a half. So that's why this is so hard.
Meditate on it.
Okay, right. Okay, now on this chart right here, we have definitions up here. The definition of a quadrilateral is a 4-sided figure. Okay, so it's got 4 sides to it. Okay, now the way this chart is drawn is whatever is true about this, everything below it will also be true. So everything here has 4 sides. Okay, now over here on this side we have a parallelogram. A parallelogram has opposite sides parallel. So that's why I drew those little things on there. Okay, so if this is a parallelogram, everything below it is also a parallelogram. Okay, now we have a special parallelogram, which is a rectangle. It has 4 right angles. That's the definition of a rectangle. Okay, so if a rectangle has 4 right angles, the square would also have 4 right angles. Over here on this side, we have a rhombus. Definition of a rhombus is that it's a parallelogram and it has 4 equal sides. So if this one has 4 equal sides, then the square is going to have 4 equal sides. So the square takes on the properties of the rectangle, 4 right angles, and the properties of the square, which is 4 equal sides. Okay, so just keep in mind that a square is a rhombus. It's also a rectangle. It's a parallelogram, and it's a quadrilateral. Now go over here to this side. Here's a quadrilateral. So this is also a quadrilateral. It has 4 sides, but it's a trapezoid. Definition of a trapezoid is 1 pair of opposite sides parallel. Okay. Now we have a special trapezoid in which it's a trapezoid. These 2 are parallel, but then also it has 2 equal sides. So let's draw that these, it is a trapezoid, definition of trapezoid, two parallel sides. So it has parallel sides, but isosceles tells us two equal sides. Okay, now, when you had high school geometry, you would work a million problems of these. And, but, you know, we'll work some, but not a million of them. Okay.
Just a couple hundred.
Yeah. Okay. Now, the example that they give you on this, is down at the bottom of page 490. You do not have to put this in your notes because it's already in the book. Okay. But this is a, let's see, it says it is a trapezoid. Now, if you look at this, definition of a trapezoid is a quadrilateral with a pair of parallel sides. So those are parallel, so I'm going to mark it to remind me that that's what that is. Now, it says you've got angle A is 130, angle B is 110. Okay, it says find the measures of the exterior angle X, okay, of the trapezoid. Okay, so we've got to figure out all these different things. Now, when you've got a figure like this, what you do is extend your parallel line like this and extend your transversal, okay? And just ignore that part over there for a minute. You see how that's just parallel lines and a transversal? So if that's 130, then what's that? 130. And why? What kind of angles?
Alternate interior.
Good. Alternate interior angles. Okay, good. Now, suppose they wanted to know the measure of angle C. Okay, I can do that. If this is a straight line and that's 130, what's that?
50.
50. Why?
Because they have to equal 180.
Have to equal 180. Now, I know three angles of this trapezoid. How can I find that one right there? What do the measures of the interior angles of a four-sided figure equal? Okay, right. So you've got 360 because the number of sides minus 2 times 180, okay, is 360. Now, I know three of them. So you just add 130, 110, 50 together. So I think that's 290. And then subtract it from 360. Is that 70?
Yes.
If I didn't make a mistake. Okay, so you can figure out anything. They could have this picture and they can have you figure out that angle right there. They could have you figure out that one right there. What would that one be? 70. Because this is a transversal and these, like this, so those are alternate interior. So, you never know what they're going to ask you, but you can just kind of put it all together and figure it out. Okay, let's see, what time is it? Alright, let's, okay, what we're going to do on this lesson, we're going to do 9 to, let's see, 7 through 53 odds, and 73 and 79. We also have worksheets to do.
Sweet. Favorite.
I think there's another one. I'm going to do two if I can find it. Maybe I don't have them, I don't know. worksheets. We're gonna take a little break first. Go back and do this, and I'm gonna check this before we go.
They really have those? Do I count those too?
Uh-huh.
Okay.
We take a break, please.
Mm-hmm. Yeah, you can go take a break.
I'm a little slower with this stuff. It's a lot to take in. I'm going to have to study it pretty good.
Hello, I speak to Nancy? Okay, all right, thank you. Bye. Hmm. That is weird. Hmm. Okay. how have things been going?
It's going well.
Okay. Class is getting harder or?
Not really.
Okay, well, good. Right. Sometimes it gets kind of bad where you've got a lot of papers and things due and all that, so I
Yeah.
didn't know.
I'm gonna go home and study up these definitions. The thing about like having the math here is I'm almost 26 now, and so it's been like
Yes.
8 years since I've even touched
I
any
know.
of this.
I've had people that were in their 50s,
Wow.
you know. I mean, it's just
And I wasn't good at it when
it's
I did
awful.
it.
Yeah. Well, how'd your surgery go? Can you see?
Oh yeah, I was telling them earlier.
Mhm.
The more it heals, the better the vision gets.
Okay, good.
So right now I'm in this awkward place where my vision without my glasses is better than it was without my glasses before the surgery,
Mm-hmm.
but it's not quite where it was with my glasses before surgery.
Right.
So like
Mm-hmm.
I'm still kind of struggling seeing right now, but
Mm-hmm.
I can see a subtle difference
Is
every
it
day.
fuzzy or anything?
It's just yeah. I mean that's
Uh-huh.
mainly what it is. This is fuzzy.
Is it LASIK?
Yeah, it was LASIK eye
Okay,
surgery.
right.
So I was
Yeah.
I was legally blind in this
Uh-huh.
eye, and this eye was much better. In fact, even now after the surgery,
Uh-huh.
like I said, it's still healing. Right now, this one, which is my good eye, is still only at 20/40, which is a lot better
Okay.
than what it was.
Yes,
But
right.
it's still, not great. But
Right.
it's getting better.
Let's do this worksheet together, if y'all don't mind, and that might help you. Okay, on this first one, the definition here is opposite sides are parallel. So what is that one going to be called?
Parallel.
Parallelogram. Okay, good. All right, number 2. What do you think that is?
Trapezoid?
Trapezoid. Right, good. Now, number 3, it looks like something, but it doesn't quite have everything that it needs to be called this. But I noticed this book
Oh,
and the ones that they're giving you,
you don't have it either.
they're not.
So
They
it's
don't have
missing
it
the
all.
right. It's missing the right angle.
Right. It should be a square, right? Okay. But it's missing the right angle. So, it, if you want to call it a rhombus or a square, it's still right. Okay. Because now when I taught geometry, we didn't do like the book did or like that. If it didn't say it, we didn't, agree that that's what it
No
was.
speculating.
Right. All right. Number 4 has a special name. It's got 2 names, really.
Isosceles right triangle?
Very good. Hasn't been as long since you've had geometry. Or that was your thing. It is so funny. Some people will be just great in algebra. Then when they get to geometry, they're like, duh, and then other people are just, the other way.
And there's some people.
And
that
then
are
some
bad at
people
both
are
of them.
good at both, and some people are bad at
That's
both.
me.
Right. Okay. What's this one?
This, it's 7 sides. Forgot.
Number 5. It's just 4 sides.
Oh, is this one? Oh, I'm sorry. I was looking wrong. Rhombus.
Rhombus. Good. Okay. What about number 6?
And
What is it?
obtuse?
Obtuse. Triangle. Number 7. As you
Heptagon.
Heptagon. Yeah. Wasn't that good? It was on number 7 also.
Yeah, I know.
Okay. All right. Number 8. According to the sides, it is a
Is it equal?
equilateral triangle. Okay. I didn't have the angles marked. If I had had it marked, it would have been equilateral and equiangular. But I didn't do that. I just did the sides. Okay. Number 9. That little part is a segment. Good. Next one is a ray. Next one is an angle. Good.
Acute.
Okay. It's just an angle.
Oh,
These shapes are on plane. What's the name of the plane? Can you read it?
Is that B? Is that a B?
P.
B.
Plane P. Okay. Alright, now someone will have to tell Bobby when he comes back what the well, I can give them to him right here.
So the next math class is the same genres of math. It's just more detailed. Is that kind of what you?
Best I can tell. I don't know which book they're using, but
He, from what I understand, from what he's told me, I think he just does his own worksheets and stuff like that.
okay, right. Yeah, as you can tell, I like to too because the book gets kind of.
Everywhere.
Okay, go ahead and finish the assignment in the book. I'll put that in.
I wonder whose idea was it to do half vinyl tile and half pretty tile.
That's on. Somebody just wanted to impress everybody but the students.
That's that convention in there, looks like they're my age or older too. My leadership, man, starting from scratch, ain't they? Man, these first few ones, like on number 13, is that an octagon?
Yeah, that's what I got.
Okay, how do I name the specific type of garbage octagon that is? And it's not a regular polygon. 13.
Octagon.
I'm not there.
It's sad. This is the most sense any of this is made in weeks, and yet it still doesn't make any sense.
Doesn't 13 have 7 sides?
8, isn't it?
I got 8. Yeah.
Oh yeah, yeah. I'm sorry.
Hey, Bobby,
Sir?
do you have a grade from English teacher?
No, sir, not yet. I think we're done. Like, no more for the rest of the semester. What you got on there, I think is you're passed.
Okay.
I
'Cause
think, don't quote me on it, buddy.
Yeah, yeah. I never quote. Yeah.
But Maverick says, we're done.
Mm-hmm. Yeah, I submit all the work and I never see the grade.
Yeah, I've emailed her like 5 times, I've texted her twice, called her like 4 times, no answer ever.
Oh.
And you know, they're like, why don't you come see her? She teaches on Monday night. I'm like, that just seems rude if I kick the door in and say, hey, answer me.
Oh yeah.
I come in with a black eye scar in the head, you tell me now. Wait.
Okay, so until you redid this one together, maybe, so when you finish it on you.
Now, this being an octagon, what kind of octagon is it? I know it's not
Nothing
regular.
special.
Nothing special? Okay. The guy that defined all these terms was Greek, wasn't he?
Mm-hmm. I'm sure.
So number 13 can call that octagon?
Mm-hmm. Weird, isn't it?
Yeah.
be sure and look in the back and check your answers. I also want to show you one up here before you get like to number 30. Let me show you this one right here. When you have a problem like this one, draw it separately, or write it in the book, whatever you want to do. But still, the little things that they put in there get in your way. Okay, you're trying to find this angle. So if that's 75, then this is 75 because they're vertical angles. If this is 133, you'd say 180 minus 133. Okay, that's 47. Then you can add these two together, subtract 180 and get that one, right? And then when you get that, then you can get that one. Okay, so 75, 47, I think that's 122. Okay, but when you have to do those, draw them big enough and get rid of all those numbers and everything, and just put the numbers in there, and then you'll be able to figure it out. And look for parallel lines and transversals on those, and it'll help you.
can go back at some point and look at 31. I'm having trouble with it.
Mm-hmm. It's right here. If you draw it separately, you know, this is 27, so that's 27. That's a straight line, so 180 minus 57. Let's see. Okay, so that's the 123. So that, let's see. Okay. Those are vertical. Okay, and then you subtract
Right there, little chicken inches in the back.
Mm-hmm.
And I thought it was right because it's got a right angle on it. It says it's scaling.
Okay.
Why would I signify it as that, not right?
Alright. Identify it as scaling isosceles and equilateral first. So none sides are equal, so it's scaling for A. B, acute, obtuse, right. So the big part would be right.
Gotcha. Thank you.
Mm-hmm. I want to show you something else just a minute, because they'll never tell you everything, and then you start working and you think, I have no clue what they're talking about. On some of these, they want to know an exterior angle. These are the interior angles. That one would be an exterior angle. Okay, so if you had like a pentagon or something, that would be the exterior angle. Okay, so now you'll understand what they're talking about on those.
So this angle and this angle we call that correspondent, right? No, this one. This one and
This one,
correspondence.
yes.
Okay, got it.
So 35 through 40, that's basically that n minus 2 times 180 formula. Is that what that is?
40 what?
35 through 40, is that that?
Uh-huh,
formula?
yep.
Gotcha.
Mm-hmm.
Wonder how much of this I'm gonna sleep off by next week.
You have to work some before you get here.
I have no idea what 41 and following is asking of me.
Okay. This is right here. If this is these are regular polygons, so that means that the sides are the same, angles are the same. Okay, so if a triangle measures are 180, you got 3 of them, then each one's 60, and they want the exterior angle, which is this one out here. So 60 from 180.
Trying to figure out what the exterior angle would be.
On this one, then you'll have to figure out, like if you've got a pentagon or something else. But they're wanting to know if you extend one of the sides, it makes an exterior angle.
So I'll do the formula here and then divide it by however many sides. So that's 8 sides. And so the formula would be 6 times 180, and then you divide it by 8, and then you get what that angle would be. And then
Yeah. A lot of steps involved there.
I better have some kind of carpentry degree after this. I was gonna say. Nobody wants that.
just stop where you are right now. But if you have a particular question, like on 29 on, if you've gotten to those, I'll work it up here for you.
47, I'm still kind of having trouble with those.
Okay. Alright. Okay, 47. One thing that you have to do always is to redraw your picture. 'Cause otherwise, it doesn't, you just can't see it, you know. So on 47, they have them kind of drawn back to back, and so you can tell which ones go together. Like if you've got, okay, they're back to back this way, but this is A, B, C, and this is A prime, B prime, C prime. So the A's go together, the B's go together, and the C's go together. If you want to turn it around, you know, and make this one like this, you know, where this is A prime, B prime, C prime, you can. Some of them I do that way. Okay, now label everything. Okay, and then you had like a 4 and a 2.4 there, and an X and a Y. Always on this kind, find the two sides that both have numbers. The 10 and the 4. Okay, that's where you start. So you go 10 is to 4 as, now I want to find X, so I go first one to the second one. First one, X is to 2.4, right? Then cross multiply, so that's 24 equals 4x, so x is 6. Is that right? Okay. If you want to do y, you still pick the same numbers. 10 is to 4 as 8 is to y. And work that out. Okay, does that make sense? Okay. So I always either, if I can see it, I'll leave them like they are. If I can't, I turn them around. Okay? What about 49 or 51? Look on 49. Just a minute. And on 49, you've got these two that both have numbers. So 4 is to 10. If you want to find x, x is to 6. If you want to find y, you still do 4 is to 10 as 3 is to y. And then cross multiply. I'm going to put these on here later. Okay, worked out and everything. This 51, you see how these two have numbers. So 2 is to 1.25 as x is to 0.75. Okay, 2 is to 1.25 as 1 is to y. Okay, you always have to match them up according to what they are. Okay, other ones, pass, you want to see 53. Look on 53, if you haven't gotten there yet, make you a note. On 53, you have to separate the triangles. And then you have to put it back in. You know, you have to take them out, put them back in. But here's this one, and here's this one. So this one is a 6, and this is a 2. Those are the two sides that have numbers. So then if you need to find, so this one is a 2 and that's a 2. If you need to find that side, you do 6 is to 2 as BC is to 2. If you need to find this side, you do 6 is to 2 as 10 is to that one. Always find the ones that go together, and that's the first thing you put down. Okay. Look at 57. On 57, this one, they're turned around. So I completely turned that one around and matched my A prime, B prime, C prime up. Because I can't see it like that. I can't even tell what they're trying to do. But I have part of the information on this one, part of the information on that one. Okay. So if the difference in these are they are congruent. That means the angles are equal, the sides are equal. So if C prime is 28, C is 28, right? If AB is 14, A prime B prime is 14. If BC is 30, B prime C prime is 30. This one's 28, and this one is 28. So if they're congruent, it's real easy, but they have them turned weird and you can't tell what's going on. Okay, let's see. Then on the next ones, if you haven't gotten here, I flipped that second one over. Look at 63. Okay, see, that makes no sense to my brain at all. So I just flipped them. They're congruent. So the sides are the same, the angles are the same. So if this one is 130, then that one's going to be 130. If this one is 70, that's 70. If this 50, that's 50. This side's 16, that one's 16, so forth and so on. Now, and it just asks you different things like what is the length of side of A prime, B prime? Okay, so if AB was 8, then A prime, B prime would be 8 because they're congruent. On 65, the length of B prime, C prime. Okay, B prime, C prime. BC was 16, so B prime, C prime is 16. That's kind of hard to say. Okay, so flip them over, turn them around, and match them up. Okay, look at 73. This one is one of those you got to separate. See, that triangle is inside here. You had to pick it up and put it over there. And then label things. The person is 6 feet tall. The distance right here is 9 feet. The distance, if this one was still in there, say the 9 feet would be there. But the 105 goes all the way over there. Now, if you've got to find this, here's the two sides that both have numbers. So this is to this as this is to this. 105 is to 9 as x is to 6. This one down here, I can see it even though they're not turned the same direction, that one goes to that one and that one goes to that one. Okay, so here's the two numbers that both the sides have numbers, so you match those up and then you do those. Okay, now I will have these pretty much worked out here. And of course you have the answers in the back so you can find them. Okay, now, so you're going to have quite a bit to do, but you've got 3 weeks to do it in. Okay. Alright, now, the next thing we're doing is lesson 9.3 on perimeter and area. So we're going to do perimeter, area, and then we're going to do volume. And that'll be all on geometry. Okay, now, the perimeter of something, if you've got a triangle, and this side is 3, this side is 5, and this side is 8. The perimeter means distance around. So you just have to add the sides. Alright, so it'll be 3 plus 5 plus 8, and it will just be like inches or feet or centimeters or whatever. If you're doing the area, it wants to know how much space is inside there. What's covered up? Okay. Okay, volume would be something like, if you had something like that, and you're trying to figure out what would fill up the space in there. Okay,
So it would be more 3-dimensional than a 2-dimensional kind of deal?
These are 2, and this is a 3. And we'll get to that later.
Volume's
This is-
what? I'm having trouble seeing that. Where do you say volume is?
Okay, it would be
It's
like
pyramid.
what is inside of the particular shape.
Okay.
It could be like a cylinder,
Yeah.
you know, but whatever is inside there, the volume. Okay, so this one is perimeter. It's just distance around a particular object. We're going to do all kinds of different objects. But the area means, you know, what all's in there. Okay. Like in this room, perimeter would be if you measured that way, that way, that way, and that way. Area would be, you've got square units, 1 foot square on each side. And you'd have to know how many squares would cover the bottom. The volume would be how much air would be in this room. You know. Okay. All right, now. Okay, so. Okay. Now, you will have on page 498 formulas for all these different shapes. Okay, so you don't have to copy this or anything, but it just has the formula. Now, when we have our final test, you'll be able to use your book and your notes. Okay, on everything.
And
Okay, I do this.
Train, right?
Huh?
And train, right?
No.
Oh, and what's the answer to 12?
No, we can't do that. Okay, but anyway, so we have different charts for different shapes. Now you're supposed to know the shapes, you know, so we'll have to work on that. All right, now let's look at some examples of how to find the area. Now it's with, or I said about algebra, you don't even have to know what you're doing if you can solve an equation and solve the formulas. And this is one of the main reasons that you'll ever need algebra, is if you had to solve a particular formula for something. Okay, now let's say we take a triangle. Okay, and it's like this. And what type of a triangle is that according to its angles?
Right.
Right. According to its sides, we don't know. We don't know yet because I don't have any numbers up there. Okay. Now let's say that okay, the base is 6, the height is 8, and this side over here is 10. Okay. So it has all three different sides. So it is a
cube?
Scaling.
Scaling. Okay. All right. Now, if we want to find the perimeter, okay, that's the distance around it. You just add 6, 8, and 10 together, right? So that's 24. Let's say these are inches. Okay. If we want to find the area, the formula for area is 1/2 the base times the height. So all you got to do, in place of the base, you put in 6. In place of the height, you put in 8. And remember, you go left to right. 1/2 of 6 is 3. 3 times 8 is 24. But this time, it will be square inches. You can also write that as inches squared. Either one of those will work. Okay, so we have the perimeter, distance around it. Area means what all is inside. How many little squares can fit in there?
If
Okay.
you're figuring out like I know this is like a rabbit hole, but if you're figuring out cubic feet, is that the same thing as figuring out like square?
Okay, cubic would be if you have a cube.
So more like a volume type.
Uh-huh, like that. All right. And you've got, say, 3 and you've got 4. Okay, like that. And saying this, maybe that's 5. Okay, so this is divided 3 this way and 4 that way. 1, 2, 3, 4. Okay, and 5 this way. So 1, 2, 3, 4, 5. And then you got to do it like that. Okay, so,
I'll take your word for it.
and so forth and so on, which we'll do that in a minute. Okay, but it would be like this times this, and that would give you little cubes that would fit inside there. Okay, now, all right, so that's, say, a triangle. Let's suppose we do the perimeter of a square. You can multiply the side times 4, or you can still just add them up. Okay, if it's a square, and it's like, say this is 3 inches, okay, and this is 3 inches. The area, you take the side and square it. Or in other words, multiply this times this. 3 squared, or 9 square inches. All right. Now, if you use a trapezoid, rectangle, you just add all 4 of them, or 2 times the length plus 2 times the width. A rectangle, you multiply length times the width. Parallelogram, okay, you just add around. The area of a parallelogram is the base times the height. You have to have a perpendicular segment in there to know the height of a parallelogram. A trapezoid is the hardest one to do, so I want to show you that one. If you've got something like this, and this is the height right here. It's always a perpendicular segment. This is base 1, this is base 2. Okay, this is side 1 and this is side 2. Okay, so you got 2 sides and you got 2 bases. It doesn't matter which one really is 1 and 2. Okay, now the formula is, for the area, is half of the height times base 1 plus base 2. Okay. Now, so you've got to have numbers on all these things. So the one we're going to do, we're going to say we have that the height is 12. Okay, base 1 is 6, base 2 is 16. Alright, and these numbers are here. What type of a trapezoid is that one? Isosceles, very good. Okay, now, so to get the perimeter, you just add 16, 13, 6, and 13, right? Okay, but on this one, half of the height is 12, and it's always a perpendicular segment, okay? Base 1, 6, plus base 2, 16. Okay, then you have to use your order of operations. So this stays here, you add this together. Is that 22? Now, go left to right, half of 12 is 6 times 22. 132 units squared. Okay, so you just use your formulas and come out with your answer. Now, of course, they'll throw in all sorts of things to make them harder. You know, they always do. Okay, now the next thing you need for this lesson is to know how to use the Pythagorean theorem. And this was named after a guy named Pythagoras. Okay. Pythagorean theorem only works on right triangles. Okay. So, and the theorem is a squared plus b squared equals c squared. Or if you know the length of two of the sides, you can square them, add them together, and then take the square root, and you can get the third side. So if we have a triangle like this, it's a right triangle. This side is 18, this side is 24, and we're trying to find the length of that side right there. So we do a squared, doesn't matter which one's a and which one's b. The only one that matters is c. This one over here is always the longest side, which is called the hypotenuse in a right triangle. So these don't matter, but you do 18 squared plus 24 squared is going to give you this side squared. Now, 18 squared, I happen to know what that is because I'm looking at my notes, is that 24 squared is 576, and that's equal to x squared. Add these together, so that's 900 equals x squared. Now, if you want to find out what x is, remember in an equation you do the same thing to both sides? You take the square root of both sides. So that gives you an x. The square root of 900 is 30. Okay, so the Pythagorean theorem will work on any right triangle. Now you don't have to put this one down, but let's say this is a 3 and this is a 5. And we want to know that one right there. We can say a squared plus b squared equals c squared. What goes in place of c squared? 5. Okay. The hypotenuse always goes in place of the c squared. Okay? So get that in your head. Doesn't matter on these. So I can do x squared plus 3 squared equals 5 squared. Now x squared, 3 squared is 9. That's 25. Okay? Solve the equation. Okay? What's x going to be?
Is that 16 or what?
16.
16 square. 4.
4. Okay, so the side of that triangle is 4. Let's look at another one. Don't have to write this one down unless you want to. A squared plus b squared equals c squared. You don't ever know where they're going to go, but you just know that c squared is where the hypotenuse is. And this is 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64. Add it up. Take the square root. What's the side? 10. Okay. Now, so when you use Pythagorean theorem, it's a squared plus b squared equals c squared. Put the numbers in, but c squared must be the hypotenuse, which is the longest side. Okay. Any questions? Okay, now you'll have problems like on 499. That's where they talked about the Pythagorean theorem. And in the case that they're talking about, these people are trying to go across this moat and get into the castle. And they don't know how long of a ladder they're going to have, because the moat's, like 18 feet. And so they put this big ladder up there, and they didn't measure, and they put it up, and then it just falls in the water, and they can't climb up there and capture the city. So, but somebody in the group knew the Pythagorean theorem, so they did 18 squared plus 24 squared equals c squared. Okay, and they found out that their ladder had to at least be 30 feet long, or they couldn't get in the castle. Okay, so some people have had to use math in the past.
Somebody built that right there while getting arrows in.
Right. Well, the mathematician was over in the woods,
I've always said every good army needs a mathematician.
Right.
Like a medic, to make sure you don't get shot.
Right. Okay. Next we have circles. Okay. So we've got a circle. If you go from the center to the side, that's the radius. Okay. If you go all the way across, what's it called? Diameter. Good. Okay, so that's the D. All right, now, if you want the circumference, which is a C, that means the distance around it. That's like perimeter, isn't it? But they have a special name for it with circles. Okay, so it's the circumference, or the distance around. And that is 2 pi r, or pi times d. All right, so suppose that the radius is 5. Okay, what would the diameter be? 10. Okay, so I can use this formula, 2 pi times 5, which would be 10 pi, or I can use pi times the diameter, which is 10. So it comes out the same, whether you use 2 pi r or pi times d. Some people can just remember like 2 pi r better than they can pi times d. Doesn't matter. Okay, now, so that gives you the distance around. Now we've talked about pi, which is 3.14. It comes from taking a circle and measuring it around it and dividing it by the diameter gives you pi. Okay, now, the area of a circle means what is inside there. Okay, how many little squares or whatever would we have to take to cover that up? So this is pi r squared. Okay, now if we got the same number here, we got pi times the radius, which is a 5 squared. All right, we know we have to do our exponents before we multiply, so that's pi times 25, or in other words, 25 pi. Okay, now on some of these, their answer will be left like this. Other ones, they'll go ahead and multiply 25 times your pi button, and get actual inches or whatever. But your answer will be squared, unit squared, okay, because it is area. Okay, now the problems that you will do on this, we're not going to do them yet, but the problems on 9-3 will be 5 through 27 odds, and 41, 51, and 53. Now let's look at that, okay, before we do it. Okay, first we have little simple problems like number 5, find the area of a triangle, using that, and using the formulas. You have rectangles, you have parallelograms, you have squares, you have trapezoids. Okay, next page you have circles. You've got to find the area and the circumference, okay, of those. Then you have to use the Pythagorean theorem on 19 through 22 and figure out what the other side is equal to. Just fill it in the formula, but remember the hypotenuse or the long side has to go in place of c squared. Now look at 23 through the rest of it. That looks horrible, doesn't it?
Yes.
Okay. Alright, let me show you that it's not as horrible as you think. Alright, let's say we take number 24. Alright, here's the square. Alright, we've got a circle inside, which is kind of hard to draw. And the radius is 5. Alright, they have this shaded part right here. And you think, that is impossible to find that out. Find the area of the shaded part. Okay, now, you think, I don't have anything. You know, how can I do that? But if this is 5, this part over here is 5, right? So from one end to the other is
Or
10. So, if it's 10 here, it's 10 down here. It's also 10 up there. If I turn that around this way, that's 5 and that's 5. So this whole side's going to be 10. Okay? So, what you have to do on these is think about moving your radius around it and figuring out, you know, how wide and how long everything is. Now, if I needed the shaded part and I took the area of the square and took out the circle, would I not have what was left? Okay, so I would do 10 squared. Area of a square is a side squared. So that'd be 100 minus the area of the circle. Alright, area of a circle is pi times r squared. The radius is 5 squared. So it's 100 minus 25 pi. You can leave it like that, or you can go ahead and actually get numbers.
I'll
Okay.
leave it like that, I think.
Yeah, I think I would too. All right, if you had some,
Sorry, you'd have to do 25 times 3.14 and then minus 100 from that, right? Either way.
25 times 3.14, and then take that away from 100. I just don't know how the answers are in the back, so you just have to do it however they are. All right, suppose I have this one. And I'm trying to get that. And I have this right here. That looks awful. But if I turn my radius around this way, this is 2, that would be 2, that would be 2, that would be 2, that would be 2, and that would be 2. So how long is it?
4. Wait.
12.
12.
Yeah.
Okay. 2, 4, 6, 8, 10, 12. How big is it this way? 4. Because if I turn this radius up this way, that's 2 and that's 2, so that's 4. So I can get the area of the big rectangle minus the area of 3 circles. Okay? And when I took those out, what would be left to be that part in between? If you have something like this, and you have a circle in here, and you want to find that right there, you see how you take the area of the triangle minus the area of the circle? Okay. Now, on that one, I'd have to give you some more information, you know, but we're not going to do that. But I'm just showing you how, no matter what the shape is, if it's like a trapezoid with a circle inside and you're trying to find that, come up with your plan first. Area of a trapezoid minus the circle will give me the shaded part. Okay? Okay, let's see what we're going to do now. I know.
Now we're in the motion.
Wait just a second. Okay, okay, so you got on 9, did I give you the ones on 9-3 to do?
Yes.
Okay. Alright, now we got one more thing, which was what Bobby wanted to know a while ago, which is volume. So I gave you 9-3, which was 5 through 27 odds, 41, 51, and 53. Okay, volume is how much is inside this particular thing. Okay. Alright, and the volume is like length times the width times the height. Okay. If you look at the bottom of page 508, it has all the different formulas there for you. You don't even have to know what you're talking about. Just fill the numbers in and you've got it. Okay, but you do have to know the shape. You've got a cube, which is like this, If you've got a rectangular solid, it's a rectangle. You know, the sides don't have to all be the same, okay? If you have a cylinder, you know, it's like this, okay? If you have a cone, got a circle on the bottom, and it goes like that, okay? If you have a sphere, okay, you kind of do it like that to show that it keeps going around. All right, so you have to recognize your shapes first, then you can use the formula. Okay, let's, if I can find one here. I don't have my notes on that. I'll just pick out one. Okay, let's say that we have the volume of this shape right here, which is a cube. And let's say that the volume, and this is 3 inches right there. If it's a cube, that means that all of them are 3, right? So, for a cube, it's the side cubed. The side is 3, so 3 cubed. 3 times 3 is 9. 3 times 9 is 27 cubic inches. Okay, you can also write that as inches cubed. All right, if you have a cylinder, now they get harder, naturally. Okay, all right, let's say that that is 2. Okay, the volume of a cylinder, this is going to be 8. The height is going to be 8. The volume of cylinder is pi r squared times h. Why do you think it's that? What's that right there? Pi r squared. That is area of a circle, right? Okay. So you get the area of a circle, then you multiply it times the height. Because volume is like 3 things. This times this times this. So you get the area of that bottom circle, pi times the radius squared times the height, which is 8. And then you get your answer. So that's a 4, and that's an 8. Okay, you can do that as 32 pi and change it, multiply it out on your calculator. When you get to here, you can just multiply it on your calculator and get the answer. Okay, but volume, remember, is 3 things. Length times width times height, basically. But it depends on your shape. If you've got a sphere, okay, that's 4/3 pi r cubed to get that. Now, if my radius is a 5, all right, 4/3 times pi times the radius cubed, and you work that out. Okay, so 4/3 pi times 5 is 25 times 5 is 125, and then you multiply these, all 3 of those together on your calculator and get the answer. So it's just a matter of working an equation.
I want to do a lot of praying over this next week.
Right. Alright, now look at the problems just a minute first. Okay, you've got all this is on volume, so you identify the shape and then you plug it into your formula. Okay, now some of these is a volume of a pyramid. Okay, the volume of a prism. Okay, so you look at your formulas in order to do this. All right, look at let's see, look at number 18. Just a minute, we don't have to do that one, but because we're going to do odds. But look at 18. This is a prism. The base of it is a right triangle, and this is 9, and this is 15, and then we've got where it makes it a prism like this, and the height of the thing is a perpendicular segment that comes down to the middle of it, and it is 13 feet. You think, how in the world can I do that? Okay, if you look on page 511, there's a formula for the volume of a prism. No matter what the prism looks like, you take the area of the base times the height. Can you tell what the base of this thing is? What shape the base is?
And
Scaling, triangle.
Okay, right. It's a triangle, right? Triangle. So you get the area of that triangle and then multiply it times height. That's all you got to do. So this big B means area of the base. The base is a triangle. And it's a right triangle. So if you go back and remember, the formula for the area of a triangle is 1/2 the base times the height. So 1/2 of 9 times 15. Then multiply it times the height, which is 13. Then just multiply those things out and you have the answer. If it is something that looks like this, okay, and it is a pyramid that's shaped like that, okay, and you're doing a volume of the base times the height, and this is a 6 and this is an 8, okay. You see the area of the base? It's a square, isn't it? Okay, so 6 times 6 is 36 times the height, which is 8. So it looks horrible, but once you figure out your shape, look on 513. So you've got these pyramids that some of them are like triangles, some are squares on the bottom, some are hexagons, and so forth and so on. So if you're going to get a volume of a pyramid, now this formula is like for the prism there, but the volume of a pyramid is 1/3 of the base times the height. Now, the reason it's 1/3 is because if this was connected like that, it would be like a prism or a big box. So when you have a pyramid, it cuts off all this shape, space around there. So it's 1/3 of the base times the height. But you have to get the area of the base. First one's a triangle, next is a square, next is a hexagon, and then the next one is a square again. So you've got some different examples of how to do these.
And which one's on 9.4 are we doing?
Okay, I'm about to get to that if I can find it.
Oh,
Okay. All right, 9.4 is 7 through 21 odds and 43, I think it is. Okay, so it's not too bad on the number, but 43 is like a pyramid in Egypt. You're going to find the volume of that. Now look at those horrible ones there, like 21 and 23 and, those sort of things. It's the same thing as that other one. If you look at 22, we don't have to do this one, but if you had this shape right here, which is a cylinder, and you took that right there, and you wanted to know what was left inside there. So you might have a job that you have to, fill up something with some fluid or something like that, and you need to know how much, okay? All right, in order to get that, you'd have to get the area of, the volume of the cylinder minus the volume of the cone. And that would tell you what was left on that. You only have one of those to do. Aren't you glad? Okay, now, before you do any of it, though, you've got to get your shapes in your mind. You have to know what a trapezoid is, know what a triangle looks like, a cube, a cylinder, a cone, a sphere, all that kind of stuff. So get that straight in your head, and then you can do it. Okay. Now, this also, these two right here will be on the lesson that you'll have to watch, online. And then this is just some more of these, just to give you a little bit more practice. And these are easier if you want to do these first.
So, we're having a lesson online this
Uh-huh.
week, is that what
Yes, yes, you missed that explanation.
Yeah, I was
Yeah.
getting late.
Yeah, we won't be here for like 3 weeks. You got a long time to get it done, but don't wait until
Yeah.
the end to get it all done, or you won't survive.
Are both of the weeks that you're,
2 or 3, okay, fine.
are both of the weeks that you're gonna be gone,
Uh-huh.
are both of those gonna be online, or just?
We're not gonna have one,
Online,
I think just one online lesson is all we'll have.
and that's next week's lesson.
Uh-huh.
Gotcha.
Okay. Everybody get 3 sheets?
Yes.
Okay.
I had all of them, and it's time to go.
I would call it hot sheets. Okay, it
They
is
don't pretty much
state
all
made
for a
for
couple weeks.
inside, and I choose to put it correct. What time is it?
It's, that time.
That time, okay. Okay, now, if you just do a little at a time, you'll survive.
Can we go back to algebra? I thought I'd say that. I miss algebra.
Right. Well, you have algebra in this.
I just wanna commit just to algebra, just one
Right,
commit.
right.
Appreciate it.
Okay.
Have a good day.
You too.
Thank you.
You're welcome. Hope it's not too overwhelming.
I think it's interesting, kind of fun.
Yeah, if you like math, that's kind of the way it is, because it's kind of a challenge. But if you don't, it's not.